Solving equations with rational coefficients. The essential question is, how is the multiplicative inverse used to solve an equation that has a rational coefficient? And notice I color-coded our two key terms here today. So the first word I'll talk about is multiplicative inverse. The definition is two fractions that multiply to give one. Okay, so those are called multiplicative inverses of each other. Here's an example. 1/2 times 2 over 1 is equal to 1. Think about it. If I half times 2, if I have 2 halves, I get a whole 1. Same is true if I have 3/4 times 4/3. Okay, so you just use a reciprocal and multiply them, and you get 1. So these are called the multiplicative inverse. The description, the numerator and denominator switch places, right? The reciprocal. Here's a non-example. 1/2 times 3/7. Those two are not related, so this is not working out. 2/3 and 5/9, again, those are not reciprocals of one another, so that doesn't work out either. The inverse property of multiplication says the product of a number and its multiplicative inverse is 1. Kind of what I mentioned already above. So 7/9 times 9/7 is equal to 1. Negative 3/2 times negative 2/3 is equal to 1. All you have to remember is you multiply by the reciprocal of the first fraction. The other word we come across is coefficient. It's the numerical factor of a term that has a variable. Okay, it's called a coefficient. Easy way to remember, look for a term, you know it because it's between pluses and minuses. So this is a positive 3x squared. So this is a whole term. All you have to look to find the coefficient is right in front of the variable. It'll tell you that there's 3 times that many. Let's try some more. Here are more examples of coefficients. Negative 4a, so the negative 4 is my coefficient. 17x squared y, 17 is my coefficient. Negative 1,400, x squared yz. So all this is being multiplied. I just look for the number up front. It's called the coefficient. This one, negative 19 times b. Again, negative 19 is the coefficient. So all those are coefficient. Here's an example of not a coefficient. 11 by itself. Nope, not a coefficient because it doesn't have any variables over here. So therefore, this is not called a coefficient. Later you'll find out that's called a constant. So let's figure out how do we use these words to solve equations. So I'm taking a look at this. 3/4 times c is my unknown is equal to 18. So 3/4 times what gives you 18? Well, if I come over here, first thing I do is I multiply each side of the equation by the multiplicative inverse of the coefficient. So what does that mean? I take a look at my actual coefficient, I flip it around, and I multiply both sides by that. So if I do that on the left-hand side, I divide out the common factors called cross-canceling, right? The 4 and 4, the 3 and the 3, that turns into 1c. It's here. Over here, I do some cross-canceling. Multiply 4 times 6 and 1 times 1, so that's 24 over 1, or just 24. And then I check my work. Always want to check my work. So I go back to the original problem, and instead of c, I'm going to replace it with 24. So I do that. I do some cross-canceling to make my life a little easier. 3 times 6 over 1 times 1 is 18. 18 equals 18. So yes, it did work out. Okay, let's see this in action again. So here's my coefficient. How do I know? I always look for my variable. It's right next to it. So first thing I do is I use a multiplicative inverse on both sides. So I flip this around, make that a 5 over 1, and multiply both by 5 over 1. I do some cross-canceling to divide out common factors. So all this turns into 1, which is my whole goal. The reason I did this is so that I get a big 1x over here. I do that. Over here, there's no cross-canceling. I just have to multiply across. So 5 times 12 gives me 60. Now, before I'm done, I want to check to see if I actually got that right. So how do I do that? Well, I substitute. Say, look, this was the actual problem. I think the answer is 60. So I substitute 60 in for x. Do some cross-canceling. 1 times 12 is 12. 1 times 1 is 1. So 12 equals 12. All right, what if the variable's on the right-hand side? Well, no big deal. You still find the coefficient. So coefficient is right here. 5/3. I use the multiplicative inverse. I'm just abbreviating here. So I flip this around and make it 3/5, and I multiply both this side and this side by 3/5, and that's what you see here. Well, this right-hand side, they're all going to cancel out. It's going to leave you with just n. Over here, I cross-cancel. The 5 and the 15 can be reduced to 1 and 3. And then I multiply. 3 times 3 is 9 over 1. And over here, all this turns into 1n. Again, I want to check my work, so I go back and plug it in. I substitute. I say, look, this was the original question right up here. Except for n, I'm going to replace it with what I think the answer is, 9. I go ahead and do some cross-canceling, double check my work, and at the end, aha, it does work out. All right, one last problem for today's video. What happens if I have a mixed numbers like this? Well, no big deal. All I want to do is I first change it to an improper fraction. Remember to do that by 4 times 6 and add the 1. That's 25 over 6. That's here. 3 times 3, add the 1. That's 10 over 3. That's there. Okay, then I just follow the same steps. Look for the multiplicative inverse of the variable. Well, here's my variable, so here's the coefficient. I flip those around. 3 over 10. I multiply both sides. I do some cross-canceling. On the side that has the variable, it should all cancel away and leave you with just the variable. On this side over here, I went ahead and did that. The 3 and the 6 turns into 1 and 2. The 25 and 10 turn into 5 and 2. And multiply. 1 times 5, 2 times 2, that's 5/4. So I get 5/4 of the answer. I want to check my work. I go back to the original question. Now, I'm not going to use this one. I'm going to go ahead and just use this one. It's the same thing. It's just an improper fraction, just to save myself a step. So here's the original question. I replace the c with what I think it is. So I do that. It's going to be multiplied. And then I multiply. 10 times 5 is 50. 3 times 4 is 12. I reduce this fraction, this side. I can reduce it, and sure enough, I get the same one. All right, make sure you come to class tomorrow with questions about this. We'll spend a lot of time on this particular chapter.